Hello there, and welcome to the Dreamy Lab channel. Tonight, we'll be drifting through the magnificent forces of nature, the hidden machinery of the universe, and the deep laws that guide every movement in the cosmos. These forces are as ancient as creation itself, and equally as mysterious. All around you, unseen powers are at work, quiet, relentless, and everywhere at once. They bind the stars, hold atoms together, and choreograph the motion of galaxies and dust alike. You can't see them, but you can feel their pull in every moment. They are the silent sculptors of reality, the reason the universe holds together instead of flying apart. From the gentle tug that keeps your feet on the ground to the cosmic threads that weave the fabric of space and time, these forces connect everything that has ever existed. If you enjoy these quiet journeys, I invite you to subscribe, or share a thought below. It helps others find their way here, too, one sleepy soul at a time. But for now, all you need to do is relax. Allow your breathing to slow and your mind to grow still. Let's begin. Gravity feels strong. It keeps oceans from drifting into the sky and holds the moon in its eternal orbit. Yet, compared to the other fundamental forces, it is astonishingly feeble. You can defeat the gravitational pull of an entire planet simply by raising your arm. The electrical forces within your muscles are trillions upon trillions of times stronger. Why does gravity dominate? Because it never cancels out. Every bit of mass, everywhere, adds its tiny pull to the cosmic total. This quiet persistence lets it weave an invisible web of connection across the void. It is the great paradox. The weakest force is also the one that binds reality, from the smallest grain of sand to the grandest cluster of galaxies. If you could stand outside the Milky Way, you would see hundreds of billions of stars circling an unseen center, held in a slow, stately dance by gravity's patient hand. Each star moves along the curved fabric of space-time, carved by the galaxy's immense mass, and woven through it all is dark matter, invisible and vast, deepening the gravitational well that anchors everything. This cosmic choreography repeats on a grander scale. Neighboring galaxies feel the same pull, drifting towards one another over billions of years in slow-motion mergers that can take cosmic ages to complete. Galaxies group into clusters, and clusters form vast filaments, weaving the very architecture of the observable universe. All of it is held in balance by the same simple law that guides an apple falling toward Earth. It is easy to imagine gravity as belonging only to planets and stars. But Einstein revealed a deeper truth. Everything with mass, everything that exists, bend the fabric of space-time. You are doing it right now. Your body, your chair, the very air you breathe, all slightly alter the paths of passing photons. These distortions are unimaginably tiny, but they are real, rippling outward as faint, permanent signatures of your presence. In a sense, gravity is not just something you feel. It is something you create. You are part of the same fabric that binds galaxies. Space itself reshapes to accommodate your existence. Proof that every living thing leaves its imprint on the universe, simply by being. Light, the fastest thing in existence, must also follow the curves of space-time. When it passes near a massive object, it doesn't get pulled. It simply follows the geometry of reality. This is gravitational lensing, a phenomenon that turns the cosmos into a natural telescope. Massive galaxies can bend the light from more distant ones, creating ethereal rings, arcs, and ghostly duplicates of entire galaxies billions of light years away. Through these cosmic lenses, astronomers can peer deep into the early universe, observing light that has traveled for nearly its entire history. Sometimes, a single beam of light loops around a galaxy more than once, arriving from multiple directions at the same time. Gravity allows the universe to magnify its own secrets. Imagine the universe as a vast, quiet ocean of space-time. When massive objects move, like two black holes orbiting each other, they send out ripples. These are gravitational waves, vibrations that stretch and squeeze the very fabric of reality. The effect is infinitesimal, less than 1,000th the width of a proton. Yet, in 2015, we felt it. The LIGO Observatory recorded a faint chirp from two black holes merging over 1 billion light years away. It confirmed that space and time are not silent. They can ring like a bell, and the universe is full of their echoes. The collision of two black holes is one of the most powerful events in the cosmos. In a fraction of a second, They can radiate more energy and gravitational waves than every star in the observable universe combined. This energy is drawn not from explosion, but from their violent motion and the collapsing geometry of space itself. What remains is a single, calmer black hole. The collision ends in absolute silence, but its ripples race outward forever, carrying the memory of that cataclysm. For centuries, gravity was thought to be instantaneous. But Einstein showed that gravity is the shape of space itself, and that shape changes at a finite speed. The speed of light. If the sun vanished, Earth would not fly off instantly. We would continue in our orbit for 8 minutes, the same time it takes for the last light to reach us, before the space-time around us flattened and we drifted away. This cosmic speed limit keeps the universe stable, preventing paradoxes. Gravity isn't a force transmitted through space. It is space updating its geometry one wavefront at a time. Gravity doesn't just bend space, it bends time. The stronger the gravitational field, the slower time flows. On Earth, this is measurable. A clock on a mountaintop runs faster than one in a valley. Your head, being slightly farther from Earth's center, ages a few nanoseconds faster each year than your feet. Near a black hole, this distortion becomes extreme. Seconds can stretch into centuries. There is no universal clock. Every tick is tuned to the local curvature of space-time, a river flowing at different speeds throughout the cosmos. We imagine Earth's gravity as a uniform pull, but it is a tapestry of variation. The field is subtly uneven, weaker over deep oceans and stronger over dense mountain ranges. It shifts with the motion of magma deep below, the flow of glaciers, and the shifting of tectonic plates. Our planet is not a perfect sphere, but a dynamic, living world, and its gravity tells a story of all that lies within. These subtle variations in gravity, often just a few millionths of the force we feel, are meticulously mapped by satellites tracing our planet's orbit. The resulting models unveil a hidden world. Ancient slabs of tectonic plates sinking into the mantle, a profound loss of mass from melting polar ice, and the silent ebb and flow of vast aquifers. The shape that defines this invisible topography is the geoid, the true undulating shape of Earth, defined not by rock and water, but by the subtle drum of its gravity. Though we never feel it, our weight and the pull beneath our feet are in constant, gentle flux as the planet breathes, melts, and drifts. Gravity, ever patient, responds to every shift within the living world. Astronauts float not because they have escaped gravity, but because they are in a state of perpetual, elegant descent aboard the International Space Station. Just a few hundred kilometers up, Earth's gravity remains nearly 90% as strong as on the ground. They are, in fact, falling. The station is hurled forward at nearly 8 kilometers per second, and as it falls toward Earth, the planet's curve falls away at the exact same rate. This creates an endless, circular plunge, a perfect balance where forward motion and downward pull achieve equilibrium. Everything inside, the astronauts, their tools, floating droplets of water, falls together, eliminating the sensation of weight. Each orbit is a quiet, continuous conversation between velocity and pull, proof that even in the void, gravity never lets go. It only changes its expression that a single photon has no mass, yet it carries a whisper of momentum, the ability to impart a gentle push. When countless photons strike a vast, mirror-like solar sail in the vacuum of space, this almost imperceptible pressure, called radiation pressure, becomes a true and constant form of propulsion. The Japanese spacecraft Ikaros proved that sunlight alone can gracefully accelerate a vessel through the void. Every second, billions of photons bounce off the sail, each imparting a tiny nudge. With endless patience, these nudges accumulate, enabling journeys across the solar system without fuel, noise, or fire. Future interstellar missions may harness powerful lasers to drive such sails to a fraction of light speed, crossing the chasm between stars in decades rather than millennia. Light, the purest form of energy, can propel worlds without ever touching them. Every spark, every magnet, every beam of light emanates from a single unified force, electromagnetism. James Clerk Maxwell unveiled this profound connection in the 19th century, realizing that changing electric fields birth magnetic fields, and shifting magnetic fields generate electric currents. Together, they weave self-sustaining waves that travel at the universal speed limit. Light itself, the warmth of a star, the hum of a city, The fury of lightning and the invisible signals carrying your voice across the planet are all manifestations of this one interaction. It is the force that allows atoms to hold together, molecules to form, and energy to travel freely across the cosmos. Every sight you see and every sound you hear exists because electromagnetism endlessly weaves energy through the vacuum of space. For centuries, electricity and magnetism seemed like separate mysteries. One produced sparks, the other guided compasses. The revelation was that they are inseparable sides of a single, invisible fabric. The electromagnetic field. Move an electric charge, and a magnetic field blossoms around it. Sweep a magnet past a conductor, and an electric current awakens. This constant, dynamic exchange is what propels energy through the universe. It is the reason light exists and why radio waves can traverse the absolute emptiness of space. Even in perfect darkness, this field is never still. It shimmers with quantum potential, alive with virtual particles flickering in and out of existence. Everything from gentle starlight to penetrating X-rays is merely a different vibration of this one universal field. Without electromagnetism, the tangible world would instantly dissolve. At the heart of every atom, a nucleus of positively charged protons is surrounded by a cloud of negatively charged electrons. The only reason this delicate architecture holds is the electromagnetic attraction between them. Without that force, electrons would drift into the void and matter would cease to be. Simultaneously, the electric repulsion between the protons and the nucleus would tear it apart if not for the overpowering embrace of the strong nuclear force. Together, these forces form a foundation of everything solid. The walls around you, the air you breathe, your own body, all exist because electromagnetism binds matter into stable, visible form. The electric signals that flash through the neurons of your brain are the same fundamental phenomenon that powers the stars. Both are symphonies of electromagnetism. In your mind, tiny ion currents travel along neural pathways, triggering the release of chemicals that create thought, memory, and sensation. In the heart of a star, immense electric charges within the searing plasma govern the nuclear fusion that forges light and heat. The difference is one of monumental scale, not underlying principle. Both operate on the same laws of attraction, repulsion, and field dynamics. When you think, when your heart beats, when you feel the sun's warmth, it is electromagnetism at work, bridging the vast expanse between the cosmic and the conscious. Lightning is a 50,000-degree river of plasma, a momentary bridge between cloud and ground. It begins with a silent, invisible buildup of electric charge within a storm cloud. When the tension becomes too great, the air itself ionizes and a jagged channel of superheated plasma, a lightning bolt, explodes downward. The temperature within this channel can exceed 50,000 degrees Celsius, hotter than the surface of the sun. What appears as a single flash is often a rapid series of discharges racing along the same path. The thunder that follows is a sound of air expanding explosively from this intense heat. Lightning is one of nature's most raw and powerful demonstrations of electromagnetism, a reminder that electricity is not our invention, but primordial force that balances the planet's own electrical heart. The northern lights are Earth's magnetic field made visible. When a torrent of charged particles from the sun approaches our world, our planet's magnetic field captures and funnels them toward the poles. There, they collide with atoms of oxygen and nitrogen in the upper atmosphere, causing the sky to glow in shimmering curtains of green, red, and violet. Each color tells a story. Green from oxygen, red from high-altitude oxygen, and purples from nitrogen. The aurora ripples and dances as the magnetic field lines themselves shift and vibrate under the pressure of the solar wind. This breathtaking beauty is a side effect of Vital Shield. Without this magnetic protection, the solar wind would slowly strip away our atmosphere. Magnetic fields do not end at the edge of our atmosphere. They stretch across the incomprehensible voids of interstellar space. Within galaxies, faint magnetic fields thread through colossal clouds of gas and dust, influencing the birth of stars and guiding the paths of high-energy cosmic rays. These fields are incredibly weak, yet they are woven across tens of thousands of light years. Astronomers trace their subtle architecture by observing the polarization of starlight, revealing how they align with the spiral arms of galaxies like our Milky Way. These immense magnetic webs, whose origins remain a cosmic mystery, are fundamental architects, shaping the evolution of matter on the grandest of scales. Our sun possesses a magnetic heartbeat. Approximately every 11 years, its global magnetic field reverses polarity. The north and south magnetic poles swap places. This cycle drives a rhythm of solar activity, from the rise and fall of sunspots to the violent eruptions of solar flares and coronal mass ejections. At the peak of this cycle, the sun's surface becomes a tempest of magnetic storms, its plasma twisted and confined by contorted field lines. This constant magnetic turmoil affects everything from satellite communications to the intensity of our auroras. The sun is not merely a ball of fire. It is a dynamic, living magnet whose influence extends beyond the orbit of Pluto, turning itself inside out with a quiet, cosmic regularity. Ultimately, the entire world of human sensation is built upon the foundation of electromagnetism. The colors you see are specific wavelengths of light, absorbed and emitted by electrons dancing between energy levels and atoms. The sounds you hear are vibrations in the air, translated into electrical impulses within the delicate machinery of your inner ear. The warmth of a surface, the scent of rain, the very structure of the molecules that compose you, all of it emerges from the ceaseless, intricate dance of electromagnetic forces between the fundamental particles of the universe. When you touch something solid, it is electromagnetic repulsion between the electrons in your hand and the electrons in the object that prevents them from merging. Even fire is an electromagnetic phenomenon, a release of light and heat as atoms shed energy. Every experience you've ever had, every sensation of beauty, warmth, or color, is a conversation between your body and the invisible, all-pervading electromagnetic field. The strong nuclear force, which binds protons and neutrons inside the atomic nucleus, is the mightiest force known. It is approximately 100 times stronger than electromagnetism and incomprehensibly more powerful than gravity. If its power could be scaled, the energy contained in a single teaspoon of this pure force could lift 1 trillion tons. This immense strength originates from particles called gluons, which glue quarks together. Its range is vanishingly small, less than 1/1,000,000,000 of a meter, but within that domain it is absolute. It powers the sun through fusion and grants all ordinary matter its stability. Without it, atomic nuclei would fly apart, and the universe would dissolve into a formless mist of radiation. It is nature's unbreakable bond, the hidden tension inside everything solid. Defying intuition, the strong nuclear force grows stronger as you try to pull it apart. When quarks are close, they move freely. But attempt to separate them, and the force between them tightens like an unbreakable rubber band. Pull with enough energy, and that energy spontaneously creates new quark pairs, forever confining them. This principle, called confinement, means no single quark has ever been observed in isolation. The universe insists that these fundamental building blocks remain together. This counterintuitive law is what ensures the stability of every atom in existence. Protons and neutrons are composed of quarks, but if you sum the mass of these quarks, it would account for only about 1% of the total. The remaining 99% of your mass comes from the pure energy of the strong force binding them, the frenetic motion of quarks and gluons confined within the nucleus. Through Einstein's E equals mc squared, this energy manifests as mass. Therefore, most of what gives you weight, what makes your body tangible, is not solid matter but the trapped, restless energy of an invisible nuclear fire. The strength that holds the universe together is literally what gives you substance that a proton is not a solid speck, but a seething quantum storm. While 3 valence quarks define it, the interior is a dynamic chaos where countless virtual particles, gluons and quark-antiquark pairs, blink in and out of existence in a continuous dance. This internal turbulence, balanced with perfect precision, is what grants the proton its stability and mass. The same quantum frenzy fills every atom in your body. On the smallest scale, matter is never still. It is a continuous flicker, creation and annihilation, an ocean of energy wrapped in the calm illusion of solidity. The sun shines because a strong force unlocks energy through fusion. Under gravity's immense pressure, hydrogen nuclei in the sun's core are forced so close that the strong force can overcome their electromagnetic repulsion, fusing them into helium and releasing energy. Every second, 600 million tons of hydrogen are fused, a small fraction of its mass converted into sunlight that sustains our world. This process is a cosmic balancing act between gravity's crush and the strong force's binding power. Every star in the night sky is a testament to this balance, a living demonstration of how strength creates light. The weak nuclear force is a quiet alchemist of the cosmos. It allows particles to transform, enabling a neutron to decay into a proton, an electron, and a neutrino. Without this process, known as beta decay, the universe would be a frozen sea of hydrogen. The weak force enables stars to synthesize the heavier elements, carbon, oxygen, nitrogen, the essential ingredient for life. It also regulates the slow, steady burn of stars, preventing them from exploding instantly. The neutrinos produce stream through you in their trillions every second. Though subtle, the weak force's influence is written into every atom of your body, transformed by its touch in the heart of a long-dead star. The weak force is carried by incredibly massive particles called the W and Z bosons. Each is heavier than an entire atom of iron, yet they act over a distance less than 1,000th of a proton's width. Their immense mass is why the weak force seems feeble and short range. It is not weak by nature, but limited by the weight of its messengers. These bosons flicker into existence for the briefest instants during nuclear reactions before vanishing. Their discovery was a triumph of physics, confirming a deep unity between the forces. Without the weak force, neutrons would be stable and inert. The chain of nuclear fusion could not begin, leaving a universe of pure, cold hydrogen. No stars, no planets, no chemistry, and no life. The weak force is the hidden engine of cosmic chemistry, the reason the universe is rich with elements and possibility. Every molecule in your body exists because the weak force gave matter the ability to change that Earth's gravity feels constant, but it is a dynamic field, subtly shifting each day as the planet's mass redistributes itself. Magma churns, ice sheets melt, oceans' tides ebb and flow, and even the way of seasonal rainfall alters the local gravitational pull. Satellites map these tiny fluctuations, mere millions of the force we feel, to track polar ice loss, monitor groundwater, and watch tectonic plates drift. The ground beneath your feet rests upon a field that changes as the planet breathes, a reminder we live on a living, dynamic world. Gravitational lensing is a universe bending its own light. When a massive galaxy cluster lies between us and a more distant object, its gravity warps the fabric of space-time, bending the light from the background object and acting as a colossal cosmic lens. This phenomenon can magnify distant galaxies, twist their light into luminous arcs, or even create multiple images of the same object. Through these natural telescopes, astronomers can peer billions of years into the past, observing the earliest galaxies and mapping the invisible distribution of dark matter whose gravity contributes to the lens. Each distorted image is a direct photograph of space-time itself in motion. Around a black hole, gravity becomes so intense that it warps space into a perfect trap for light itself. This region is the photon sphere, where space-time is curved so steeply that photons can orbit the black hole in a perfect, circular path. They are caught in an eternal loop, neither escaping nor falling in. If you could observe this, you would see a ring of distorted starlight, a ghostly halo wrapping the abyss. It is one of the most extreme thresholds in nature, a place where geometry itself becomes a mirror and light is sentenced to an endless journey. IT is this very region, the photon sphere, that creates the luminous rings captured in the first historic images of black holes by the Event Horizon telescope. The light forming those halos has been bent into a circular path, skirting the abyss multiple times before some of it escapes to reach our telescopes. Its trajectory is carved by the deepest gravity known to exist, a perfect signature of space-time warped to its extreme. Even our home, the Milky Way, acts as a colossal gravitational lens. Its immense collective mass, stars, dark matter, and all, subtly warps the light from galaxies billions of light years behind it. For astronomers, this is a double-edged sword. It slightly distorts our view, but also magnifies the faint glow of the universe's earliest galaxies, bringing them into focus. By meticulously measuring these tiny warps, scientists can chart the invisible halo of dark matter that envelopes our galaxy, a vast, unseen scaffold that dictates its shape and motion. It is a subtle but constant proof that gravity is an ever-active sculptor, its influence stretching across cosmic time to shape our very perception of the cosmos. Gravity binds the universe, yet it possesses a unique and profound property. It can never be blocked or shielded. You can hide from light behind a wall, and magnetic fields can be canceled, but gravity passes unimpeded through every material, through planets, through lead, through your own body. This universality is what makes it so elusive to study, and so ultimately powerful on the cosmic stage. Every mass attracts every other, regardless of the distance or what lies between. Over the vast gulfs between galaxies, where all other forces fade into irrelevance, gravity alone remains, patiently sculpting the large-scale structure of reality. It is the one force woven into the fabric of existence itself, from which there is no escape. Gravity pulls everything together, yet the universe as a whole is not only expanding, it is accelerating. This baffling phenomenon is driven by a mysterious entity we call dark energy, a form of energy inherent to the fabric of empty space itself, which pushes galaxies apart. We do not yet know what dark energy is, but we know it constitutes about 70% of all the energy in the cosmos. The result is a grand cosmic tug-of-war. Gravity pulling inward, dark energy pushing outward. The stars you see tonight drift ever farther apart, carried on a tide of expansion that began nearly 14 billion years ago and shows no sign of ending. Magnetic fields are a universal constant, generated wherever charged particles are in motion. They exist around every star, every planet with a molten core, and every swirling galaxy. Earth's field protects us and paints the auroras. The sun's field drives its explosive cycles. And in the deep void between stars, faint magnetic filaments weave through clouds of gas, guiding the birth of new solar systems. These cosmic fields, often invisible, are detected by the way they polarize starlight, revealing structures that span tens of thousands of light years. Magnetism ties the smallest particle to the motion of the galaxy, uniting scales that differ by trillions of times. Magnetic fields do not require matter to exist. They can permeate the pure vacuum of space. When these fields change, they generate electric fields and vice versa, a self-sustaining dance that maintains their presence in what seems like nothingness. Vast magnetic lines thread the interstellar void, storing energy and guiding wandering cosmic rays. During solar storms, these invisible lines connect with Earth's magnetosphere, releasing energy that can disrupt our technology. The vacuum is not empty. It is a humming medium alive with invisible fields that span the cosmos. With every beat, your heart generates a tiny, measurable magnetic field. The coordinated electrical impulse that triggers the muscle's contraction produces this faint signal, which sensitive instruments can detect from outside your body. The same is true for your brain. The firing of neurons creates magnetic patterns that can be mapped. You are, in a literal sense, a magnetic being. The electrical rhythms of your life create ripples in surrounding electromagnetic field, a beautiful proof that the same laws governing galaxies also hum softly within you. The sun's surface is a seething plasma crisscrossed with magnetic field lines. As the plasma churns, these lines twist and knot until they snap and reconnect in a violent event known as a solar flare. In minutes, a single flare can release energy equivalent to billions of nuclear bombs, hurling charged particles across the solar system. When this storm reaches Earth, it can trigger technological chaos and brilliant auroras. Solar flares are a stark reminder that stellar magnetism is not a static force, but a dynamic and explosive one, linking our world directly to the sun's fiery heart. The auroras that dance at the poles are the direct result of these solar storms. When charged particles from a flare or coronal mass ejection are captured by Earth's magnetic field, they are funneled toward the poles and collide with atoms in the upper atmosphere. This collision transfers energy, causing the air to glow in shimmering curtains of green, red, and violet. The specific colors depend on the type of gas struck. Oxygen glows green and red, nitrogen blue, and purple. The serene beauty of the aurora is the visible edge of a global electromagnetic storm, a breathtaking display of our planet's connection to its star. The strong nuclear force is carried by particles called gluons, nature's ultimate glue. Inside every proton and neutron, gluons constantly exchange between quarks, weaving a dense, self-interacting web of force. Unlike the photon, which is a carrier of electromagnetism, gluons interact with each other, creating a confining field from which nothing can escape. This web is so potent that it generates nearly all the mass of ordinary matter, not through the weight of the particles, but through the sheer energy of their motion and binding. Every atom and every living being owes its solidity to this invisible, dynamic network. Quarks can never be observed in isolation, a principle known as confinement. If you try to pull two quarks apart, the energy in the stretching flux tube of the strong force becomes so great that it spontaneously creates a new quark-antiquark pair. Instead of freeing a single quark, you simply get two new bound particles. This unbreakable law ensures the stability of all atomic nuclei. Without this confining promise, matter would instantly disintegrate into a formless cloud. The strong force is the universe's guarantee of permanence. Not a single proton is a storm of energy. The three quarks at its core are nearly massless. They account for only about 1% of the proton's total mass. The remaining 99% comes from the kinetic energy of the quarks and the binding energy of the gluons themselves. Through Einstein's E equals mc squared, this pure energy manifests as mass. You are not made of solid, static matter, but of motion condensed into permanence, a restless internal storm given tangible form. A neutron star is the ultimate testament to the strong force's power. When a massive star dies, its core collapses under gravity's immense crush. Electrons and protons are forced together to form neutrons, and the collapse is only halted when the pressure from the strong nuclear force, resisting further compression, finally balances the inward pull of gravity. The result is a neutron star, a city-sized object barely 20 kilometers across, yet containing more mass than our sun. It is a perfect cosmic standoff, where gravity and the strong force fight to a permanent, breathtaking stalemate. A single teaspoon of neutron star material will weigh billions of tons, a density so extreme it defies earthly comparison. Inside, gravity pushes inward with a force that crushes atoms themselves. Yet the strong nuclear force pushes back with equal might, creating a perfect, eternal standoff that prevents a star from collapsing further into a black hole. The entire object is a monument to balance, a sphere where the two most extreme forces in nature, attraction and repulsion, are frozen in opposition. Its surface glows with the heat of trapped radiation and intense magnetic fields, a luminous remnant of the cosmic battle that forged the universe's most compact form of matter. Without the strong nuclear force, every atomic nucleus in the universe would instantly explode. Protons, all positively charged, repel each other fiercely due to the electromagnetic force. The strong force acts as nature's ultimate cosmic glue, overpowering this electrical repulsion at incredibly short ranges, binding protons and neutrons together into stable nuclei. This force is so potent that it outweighs electromagnetic repulsion by a factor 100, yet its influence is confined to a space smaller than a proton. This delicate balance between the repulsion of electricity and the attraction of the strong force defines the very existence of solid matter. Without it, everything would dissolve into a formless, dispersing cloud of charged particles. Most fundamental laws of physics are ambidextrous. They treat left and right as identical. The weak nuclear force, however, breaks this mirror symmetry. It interacts only with left-handed particles, those that spin in a specific orientation. This inherent bias, discovered in the 1950s, shattered a long-held principle and revealed a fundamental asymmetry woven into the fabric of reality. This hand-deadness manifests in radioactive decay and is an immutable property of neutrinos. While its origin remains a profound mystery, this tiny imbalance may be one of the most important reasons that anything made of matter exists at all in the universe's first moments. The Big Bang should have created equal amount of matter and antimatter, which would have subsequently annihilated, leaving behind a sea of pure light. Yet, we exist in a universe dominated by matter. Physicists believe the weak force's violation of symmetry provided a crucial escape clause. In certain interactions, it treats particles and antiparticles slightly differently, allowing a minuscule fraction of matter, roughly 1 part in a billion, to survive the Great Annihilation. That surviving sliver became every galaxy, star, planet, and living thing. Your very existence is a direct consequence of this subtle bias written into the weak force, a tiny preference in the laws of physics that allowed the cosmos to be material. While the strong force builds atomic nuclei and electromagnetism binds atoms into molecules, the weak force is a quiet sculptor of the universe's chemical diversity. In stellar cores, it facilitates the transformation of protons into neutrons and back again, governing the nuclear reactions that forge new elements and determining the lifespan of stars. Without its subtle influence, the universe will be frozen in a state of pure hydrogen, incapable of producing the heavier elements essential for planets and life. It operates without flash or spectacle, but its influence defines the entire periodic table. Every atom of carbon, oxygen, and iron owes its existence to this gentle alchemist that allows matter to transcend its original form. Neutrinos, created by the weak force in stars, supernovae, and the Big Bang, stream through your body by the trillions every second. They are the most elusive particles known, interacting so feebly with matter that they pass through you, through the entire Earth, and back out into space as if it were a vacuum. They interact only via the weak force, making them nearly invisible. To catch them, scientists build colossal detectors deep underground, waiting for the rare instance a neutrino collides with an atom to produce a telltale flash. These ghostly particles are cosmic messengers, carrying untampered information from the hearts of stars and the most violent explosions in the universe, proving that even empty space is teeming with silent, unseen traffic. Einstein's general theory of relativity revealed that gravity bends not only space, but time itself. He redefined gravity not as a force, but as a curvature of space-time caused by mass and energy. This curvature affects the flow of time. The stronger gravity, the slower time passes. On Earth, this effect is tiny but measurable and must be accounted for in GPS satellites to maintain their accuracy. Near a black hole, this distortion becomes extreme. Time slows to a near standstill. Gravity, therefore, is not just about why things fall, but about why time itself flows at different rates throughout the cosmos, tying every moment we experience to our place in the universe's curved geometry. From an external perspective, time stops entirely at the edge of a black hole. Imagine watching a spacecraft approach the event horizon. Its signals would stretch out, becoming slower, redder, and fainter, until they seemingly freeze on the brink, never quite vanishing but becoming infinitely delayed. To an outside observer, the ship is eternally suspended. Yet, for the astronaut aboard, time flows normally. They cross the event horizon in a matter of seconds, unaware of their own frozen legacy. This paradox lies at the heart of relativity. Time is not universal, but personal. The event horizon is more than a boundary in space. It is a shore with a river time. From an outside view, appears to meet an ocean of stillness that Einstein's genius was to replace the mysterious force of gravity with the tangible concept of geometry. Matter and energy instruct space-time how to curve, and that curved space-time, in turn, dictates how matter and energy move. A planet orbiting a star is not being pulled. It is simply following the straightest possible path, a geodesic, through a warped spatial geometry. Even massless light bends its path, not because a force acts on it, but because it travels faithfully along the curved fabric of the universe. The sun does not reach out and tug the Earth. It merely creates a dimple in space-time, and our world glides within that cosmic contour. In truth, the Earth is in a state of perpetual freefall around the sun. The sun's mass creates a deep well in space-time, and our planet follows this curvature. We are constantly falling toward the sun, but our tremendous lateral velocity means we forever miss it. The curved geometry of space turning our descent into an endless, elliptical orbit. This motion is natural and effortless, a cosmic dance dictated by shape, not force. The moon's path around Earth follows the same principle. If the sun were to vanish, the space-time around us would instantly flatten, and Earth would cease its curved fall, drifting into the void in a straight line. This understanding transformed gravity from a mysterious attraction into a beautiful and precise description of the dynamic stage upon which the universe unfolds. Every planet is a traveler, following the invisible, sculpted contours of space-time carved by its star. Even the subtle tilt of an orbit or the faint wobble of a planet acts as a celestial cartographer, revealing the unseen contours of space-time carved by its star. From the tiniest moon to the grandest galaxy, every object follows these natural curves not through conscious effort, but through geometric inevitability. The profound beauty of gravity lies in this emergent order. Every orbit is a graceful, silent response to the hidden shape of reality itself. The electromagnetic spectrum is continuous, unbroken tapestry of energy, spanning from long, gentle radio waves to deadly, penetrating gamma rays. Light is far more than what our eyes perceive. At one end, radio waves, stretching for kilometers, carry our communications and whispers from the cosmic dawn. Microwaves heat our food and map the structure of the early universe. Infrared radiation reveals the warmth of living bodies and forming stars. Visible light is but a single narrow band that paints our world in color. Ultraviolet rays carry enough energy to tan or burn. X-rays penetrate flesh to reveal the skeleton beneath. And at the far end, gamma rays, born in the violent deaths of stars and collisions of black holes, hold the power to tear apart atomic nuclei. All of these are manifestations of the same fundamental phenomenon, self-sustaining oscillations of electric and magnetic fields, all traveling at the universal speed limit. The speed of light, the Wi-Fi that connects your device, the sunlight that warms your skin, the X-rays that diagnose an injury, and the microwaves that cook your food are all the same phenomenon, differentiated only by the frequency of their vibration. It is this frequency that dictates their behavior. Long, slow waves carry data and broadcast signals. Faster oscillations create the sensations of heat and visible light. The most rapid high-frequency vibrations produce X-rays and gamma rays, carry enough concentrated energy to break molecular bonds. Yet, despite their vastly different effects, they all race to the vacuum at 300 million meters per second. The universe speaks a single, unified electromagnetic language, from the most advanced human technology to the light from the most ancient quasar, all communicating to the same rhythmic vibration of intertwined fields. A changing magnetic field creates an electric current, and a moving electric charge generates a magnetic field. This inseparable partnership, codified by Maxwell, is the engine of modern civilization. Power plants harness this by spinning giant magnets within coils of wire, inducing the electric current that powers our world. An electric motor simply reverses the process, using current to create magnetic fields that drive motion. This elegant, self-perpetuating relationship is embodied perfectly by light itself, a way where the electric and magnetic fields continuously regenerate one another as they travel. Every time you flip a switch, you are tapping into this fundamental cosmic dance, transforming invisible motion into usable energy. This elegant feedback loop powers every generator on Earth. Whether driven by steam, falling water, or wind, the principle remains unchanged. Kinetic energy is converted into electricity through the relentless interplay of coils and magnetic fields. The magnetic field is the invisible bridge between the physical world of motion and the modern world of electrical energy. From the massive turbines of a hydroelectric dam to the small alternator in a car, this 19th century discovery sustains our technological heartbeat, connecting the physics of our appliances to the electromagnetic dynamics that govern the swirling plasma of our sun. When certain materials are cooled to temperatures near absolute zero, they become superconductors, expelling magnetic fields entirely and allowing magnets to levitate in midair. This remarkable phenomenon, known as the Meissner effect, occurs because perfect electrical currents flow on the superconductor surface, creating a mirror field that repels the magnet. These currents encounter no resistance and could, in theory, flow forever. This is more than a laboratory curiosity. It is a glimpse into a world of frictionless physics, enabling technologies like maglev trains and underpinning the delicate quantum states in advanced computers. A floating magnet is a silent testament to the perfection hidden within nature's laws. The strong nuclear force is nature's ultimate binding agent, holding atomic nuclei together against the tremendous repulsion of their positively charged protons. Yet, this same force is the key to unlocking nuclear energy. In fusion, light nuclei like hydrogen are forced together until a strong force snaps them into a new, more stable configuration like helium, releasing the excess energy as light and heat. In fission, heavy, unstable nuclei like uranium are split, and the resulting fragments are more tightly bound by the strong force, again releasing energy. Both processes tap into the same nuclear binding energy, converting a tiny fraction of mass into a colossal amount of energy. As described by Einstein's E equals mc superscript 2, the strong force is responsible for the sun's power and the promise of nuclear energy on Earth. In the solar core, at temperatures exceeding 15 million degrees, hydrogen nuclei fuse into helium, releasing the energy that has sustained life for billions of years. On Earth, We harness the same principle by splitting heavy atoms in nuclear reactors. The sunlight that warms your skin and the power from a nuclear plant both originate from the same source. The conversion of mass into energy through the relentless, powerful bond to the strong force. The strong force is mighty but intimately local. It operates only at subatomic distances, less than a trillionth of a meter, smaller than a proton. This incredibly short range is crucial for the universe's stability. If it acted over longer distances, atomic nuclei would merge uncontrollably, collapsing all matter into dense nuclear matter. Within its tiny domain, however, it is the undisputed master, overpowering electromagnetism to create the stable nuclei that form the bedrock of the visible world. The carriers of the strong force, gluons, are unique. Unlike the photon of electromagnetism, gluons themselves carry color charge, the very property they mediate. This makes the strong force self-interacting and intensely complex. Inside a proton, gluons constantly split and recombine in a chaotic, energetic storm. This very chaos produces stability. The wild energy of the gluon field is what gives protons and neutrons nearly all their mass. Out of this quantum turbulence arises the calm solidity of the atom. The weak nuclear force is a quiet craftsman behind the elements of life. It allows particles to change their very identity, turning a proton into a neutron or vice versa, through processes like beta decay. This is the alchemy that allows stars to forge elements heavier than helium. Without the weak force, fusion would stall, and the universe would contain only hydrogen and helium. It is the weak force that enables the creation of carbon, oxygen, and nitrogen, the fundamental ingredients of life. In the cataclysmic explosions of supernovae, it helps scatter these elements across space, seeding future generations of stars and planets. If the weak force vanished, the universe would be stillborn. Your body is built from atoms that were forged in stars, a process entirely dependent on the weak force's ability to transmute elements. It enables the radioactive decay that warms the Earth's interior and helps sustain our protective magnetic field, though it acts only on the smallest scales and seems feeble. The weak force is life's hidden architect. You exist because the universe, through the subtle interaction, learned how to change. Gravity provides a universe with its grand architecture, drawing matter together to form stars, and sculpting those stars into vast, swirling galaxies. It is the master sculptor of cosmic form. Electromagnetism, in turn, makes that architecture visible and alive. It is the force that ignites the stars, causing them to shine with light and heat, and that orchestrates the complex chemistry on planets that leads to life. One force builds a cathedral. The other fills it with light, color, and the possibility of life. But gravity alone would leave the universe a dark, silent sculpture. It is electromagnetism that breathes life into the cosmos, bringing light and motion. The energy released from nuclear fusion in stars is carried outward by electromagnetic radiation, illuminating the void. Magnetic fields thread through galaxies, choreographing the flow of plasma, guiding the birth of new suns, and focusing titanic jets of energy that stream for thousands of light years into the emptiness. These two forces, working in concert, create the dynamic architecture we observe. Gravity is the sculptor, carving the grand forms. Electromagnetism is the artist, filling them with color, heat, and chemistry. Without one, the other would be incomplete. The Milky Way's soft glow across the night sky is the visible harmony between them, a portrait of how attraction and illumination coexist to create beauty on the largest possible scale. And within the hearts of those shining stars, two invisible forces work in tandem to build the very stuff of reality. The strong nuclear force is the unbreakable bond, locking protons and neutrons into stable nuclei. The weak nuclear force is a subtle alchemist, allowing them to transform, enabling the chain reactions that forge new elements. Every atom of carbon, every nucleus of oxygen, every particle that constitutes your body, your world, and the air you breathe was synthesized through this intimate partnership. The balance between them dictates a star's lifespan and its spectacular demise, whether it fades into a silent ember or explodes, scattering its elemental riches across the galaxy. From the quantum realm of the atomic nucleus to the chemistry of life, the strong and weak forces quietly weave the fabric of existence, one nucleus at a time. Ultimately, all four forces together in concert define the structure of reality. Every star, every cell, every fleeting thought is a result of their exquisitely tuned balance. Gravity binds the cosmos on the grandest scales, gathering matter into galaxies. Electromagnetism shapes atoms, creates light, and drives the chemistry of life. The strong force forges the atomic nuclei, while the weak force allows them to change and diversify. Each force dominates its own realm, yet their interdependence is absolute. If the strength of any one were altered by even a hair's breadth, the universe would collapse, burn out, or never form at all. Every breath you take is a fleeting harmony among these four fundamental notes in nature's grand, enduring symphony. Gravity is 1,000 billion times weaker than the strong force. This staggering weakness is what makes its cosmic dominance so profound. The gravitational attraction between two protons is negligible compared to the nuclear force that binds them. Yet, because gravity only attracts and never cancels out, and because its influence accumulates with every particle, its power becomes absolute on large scales. Stars, planets, and galaxies are massive enough for gravity's collective patient pull to overcome all other forces. This very weakness is also a gift. It allows for stable orbits, gentle tides, and the long, slow evolution of the cosmos. The mightiest structures in the universe are shaped by the gentlest of all forces. The photon, the carrier of light, is massless. This is why a beam of light, once born, can travel forever through the vacuum of space, never tiring, never slowing from the universal speed limit. A photon from a primordial galaxy carries its story for billions of years without alteration, a perfect messenger from the deep past. In contrast, the carriers of the weak force, the W and Z bosons, are immensely heavy. This great mass is why the weak force is so short-range, confined to the subatomic world. These heavy bosons can only flicker into existence for the briefest instant, mediating the transformations that power stars and build the elements of life. Meanwhile, the gluon, carrier of the strong force, is also massless but is forever confined within the nucleus, its limitless range turned inward, binding matter into existence through a storm of self-interacting energy. One of the great triumphs of modern physics was uniting electromagnetism and the weak force into a single electro-weak interaction. This revealed that extremely high energies, like those in the infant universe, these two seemingly distinct forces merge, behaving as one. This process, known as symmetry breaking, occurred as the expanding cosmos cooled, causing a single, unified force to fracture into separate identities we recognize today. This discovery is a glimpse into a deeper truth. In the first moments of the Big Bang, all four fundamental forces were one. Gravity, electromagnetism, and the nuclear forces were fused in a state of perfect symmetry. As the cosmos cooled, they split apart, freezing into distinct laws that now govern everything from the orbit of planets to the firing of a neuron. To study the forces is to trace our cosmic history backward, toward that initial, unified spark. It is to understand that the complex symphony of nature we witness today emerged from a single, fundamental note, a note for which all reality still echoes. With each break in symmetry, new particles blinked into existence, and the fundamental properties of matter emerged. What had been a smooth, uniform reality became structured, diverse, and rich with possibility. Symmetry breaking is one of the most profound ideas in physics because it explains how the entire complexity of our universe arose from an initial state of perfect simplicity. The cosmos we inhabit is not the original, pristine version, but the cooled and crystallized aftermath, a beautiful, ordered shattering of that primordial unity. Permeating the vacuum of space is an invisible energy field known as the Higgs field. As particles move through this cosmic medium, they interact with it. Those that interact strongly are slowed, acquiring property we know as mass, while others, like photons, pass through freely, remaining massless. The W and Z bosons, the carriers of the weak force, owe their great mass entirely to this interaction. Without the Higgs field, they would be massless and travel at light speed, and the weak force as we know it would cease to exist. The discovery of the Higgs boson in 2012 confirmed this mechanism, revealing the field that allows the dazzling diversity of matter, from electrons to quarks, to coalesce into tangible, solid things. It is a reason particles can clump into atoms and atoms into worlds. Without the Higgs mechanism, reality would be a ghostly, formless sea. all fundamental particles would be massless, racing eternally at the speed of light. They would never slow, never bind, never form the stable structures that make up stars, planets, or life. There would be only endless, ethereal radiation streaming through an empty void. The Higgs field provides the necessary drag, the gentle resistance that turned frenetic energy into substantive matter. It did not merely give a universe mass. It gave it structure, stability, and the possibility of permanence in a cosmos that could have been nothing but fleeting light. In the quantum realm, every force is a carrier particle. Photons for electromagnetism, gluons for the strong force, and W and Z bosons for the weak. Gravity alone remains the holdout. Its hypothetical particle, the graviton, has never been found. If it exists, it would be massless, travel at light speed, and transmit the curvature of space-time in discrete packets. Yet, gravity is so weak on small scales that isolating a single graviton is beyond our current technology. Instead, we observe its collective effects through the ripples of gravitational waves, space-time vibrations from colliding black holes that behave as a chorus of gravitons would. Finding the graviton will be the final step in unifying gravity with the quantum world, closing one of the most profound gaps in our understanding. Some theories propose that gravity is not a fundamental force at all, but an emergent phenomenon arising from the way quantum information is organized. In this view, space-time itself is a hologram, and gravity is a side effect, a collective behavior born from the deep, invisible links of quantum entanglement. Others suggest that gravity's profound weakness is a clue that it leaks into hidden, curled-up dimensions beyond our perception, its strength diluted as it spreads through a richer, multi-dimensional fabric. These radical ideas challenge our very conception of reality, suggesting that space, time, and gravity may be illusions woven from a deeper, more fundamental logic. At the heart of every star, a magnificent equilibrium reigns. Gravity pulls inward, compressing the stellar core with immense force, while the energy released from nuclear fusion pushes outward with equal might. This perfect balance keeps a star stable for billions of years. The sun's calm radiance is the visible signature of this eternal struggle, a dance of attraction and release that has warmed our world since its beginning. Every point of light in the night sky is the same tug-of-war made visible. When this balance fails, cosmic extremes are born. Black holes. When a massive star exhausts its fuel, gravity wins absolutely. With no outward pressure to resist, the core collapses until space-time folds on itself, creating a region from which not even light can escape. A black hole is gravity's ultimate victory, a monument to its relentless, patient pull. White dwarfs. In stars like our sun, the end is less violent. The dying core becomes a white dwarf, where gravity's crush is met not by fusion, but by quantum mechanical pressure, the stubborn refusal of electrons to be squeezed together. This delicate stalemate creates a dense, fading ember, a sphere of Earth size containing the massive sun. Neutron stars. For more massive stars, the collapse continues, crushing atoms until protons and electrons merge into neutrons. Here, gravity's inward press is met by the powerful nuclear force repelling compression of neutrons. The result is a city-sized object of unimaginable density, where the fundamental forces meet at the very edge of total collapse and a supernova. All four forces clash in a single violent instant. Gravity triggers a cataclysm by collapsing the core. The strong and weak forces frantically reshape atomic matter, forging heavy elements. Electromagnetism carries the story away in a blinding flash of light and expanding shock waves. This brilliant explosion, which can outshine an entire galaxy, scatters the elements of life, carbon, oxygen, iron, even gold, across interstellar space. Supernovae are both an end and a beginning, a dramatic demonstration of how the fundamental forces govern existence, from the smallest atom to the largest galaxy. In their fire, the universe remembers how to begin again thus. The cosmos is a story told by four fundamental voices. Electromagnetism repels and connects, giving us light and chemistry. But it is a strong force, with its infinite stubbornness, that resists separation, binding the nucleus against electrical rebellion. The weak force quietly sculpts, allowing matter to change its identity. And gravity, the weakest of all, patiently gathers the scattered pieces, building the grand architecture of galaxies. Together, In a symphony of attraction, repulsion, transformation, and persistence, they weave the single magnificent tapestry of reality. The electromagnetic force is a familiar architect of our tangible world, the force behind the chemistry of life, the pull of a magnet and the fury of a lightning storm. It governs through a delicate dance of attraction and repulsion, a balance of positive and negative charges in perpetual motion. We live comfortably within its domain, surrounded by its creations. The strong nuclear force, however, operates in a different realm entirely. It is a silent sentinel binding the very heart of matter. Within the atomic nucleus, protons, all positively charged, should violently repel one another. Yet, they remain locked in intimate embrace because a strong force overwhelms their electromagnetic rebellion by an almost unimaginable margin. Its most profound mystery is that it grows stronger with distance. The farther quarks are pulled apart, the more the universe resists their division. In particle accelerators, the energy used to separate quarks does not free them, but instead spontaneously creates new bound pairs. The strong force does not merely bind. It enforces an indestructible unity, ensuring the fundamental fabric of reality remains whole. A simple magnet is a testament to the power of perfect coordination. Its power arises from the collective alignment of trillions upon trillions of atomic spins. Each electron acts as a tiny magnetic compass, and in most materials, these point in random directions, canceling each other out. But in a magnet, vast domains of these atomic arrows align in perfect unison. This disciplined cooperation creates a collective magnetic presence powerful enough to reach across space and exert force. The magnet in your hand is a quiet miracle of atomic cooperation, demonstrating how unity at the smallest scale generates tangible power at our own. The pulsar represents magnetism forged in the crucible of stellar collapse. This city-sized remnant of a supernova packs a sun's worth of mass into a sphere just kilometers across, spinning hundreds of times per second. Its magnetic field is almost beyond comprehension, 1,000 trillion times stronger than Earth's. This titanic field can strip electrons from atoms thousands of kilometers away, turning nearby space into a storm of radiation and ionized gas. As it rotates, the pulsar emits lighthouse-like beams of energy that sweep through the cosmos with metronomic precision. A pulsar is proof that magnetism, when taken to the extreme, can shape the very behavior of space-time, transforming a gravitational corpse into a spinning engine of cosmic order. A single lightning bolt is a breathtaking concentration of raw electromagnetism. Within a thundercloud, the separation of electrical charges builds a tremendous voltage until the air itself can no longer resist. The resulting discharge is a river of plasma, hotter than the surface of the sun, carrying enough energy to power an entire city for several seconds, all released in a flash lasting less than a heartbeat. This brilliant, branching path of ionized air, connecting heaven and earth, is a pure expression of the same electromagnetic laws that govern the orbits of planets and the light of distant galaxies. A fundamental truth of our universe is that every electric current generates a magnetic field that curls around its path like an invisible vortex. This discovery, which unified electricity and magnetism, powers our modern world. From the electric motors in our appliances to the vast dynamo of Earth's molten core that generates our protective magnetic shield. Even the faint currents of thought in your brain create a tiny, detectable magnetic field. Magnetism is not separate from electricity. It is its inseparable shadow, a beautiful geometric consequence of moving energy. Even a single electron in motion is an event that reshapes the space around it. As it moves, it drags its electromagnetic field along, instantly influencing its environment. In the quantum realm, this is even stranger. The electron is surrounded by a haze of virtual particles that flicker in and out of existence, modifying its influence. When it accelerates, it emits ripples of pure electromagnetic energy, photons, that can travel across the universe. Every flicker of light begins with this microscopic sculpting of reality. The strong nuclear force is mediated by 8 distinct types of gluons. These massless particles carry unique combinations of color charge, a quantum property that acts as the source of the force. Gluons constantly exchange between quarks, creating a dynamic, self-interacting web of energy. Because they carry charge themselves, they can interact with each other, leading to the incredible complexity of quantum chromodynamics. Yet, from this subatomic storm emerges perfect stability. The dance of 8 types of gluons is what binds the universe together at its most fundamental level. In a beautiful paradox, these massless gluons create nearly all the mass of the visible universe. The interior of a proton is a turbulent sea of gluon energy, so dense and powerful that it accounts for over 99% of the proton's mass. Through Einstein's E equals mc squared, the pure energy of their binding force becomes tangible substance. When you feel the weight of a stone, you are not feeling the mass of static particles, but the weight of confined energy, the relentless, swirling tension of countless gluons holding reality together. The weak nuclear force is the quiet heartbeat of unstable atoms. It governs radioactive decay, allowing neutrons to transform into protons and vice versa, emitting electrons and neutrinos in the process. Though its reach is subatomic, its role is cosmic. It sets the tempo for stellar fusion, determines the lifespan of radioactive elements, and is the reason stars burn steadily for billions of years instead of exploding instantly. The weak force is the universe's silent timekeeper, guiding the slow, inevitable transformation of matter. This weak force-driven radioactivity is the hidden engine of our living planet. The decay of elements like uranium and thorium in Earth's deep interior provides a steady, billion-year heat source. This heat keeps the outer core molten, driving the colossal convection currents that generate Earth's magnetic field through the geodynamo effect. This magnetic shield protects us from solar and cosmic radiation, making life on land possible. The rumble of volcanoes and the drift of continents are surface expressions of this deep, atomic-powered warmth. The weak force, from the depth of the atom, sustains the very habitability of our world. While Einstein described space-time as a smooth curved fabric, quantum mechanics reveals a far wilder truth. At the tiniest conceivable scale, the Planck length, space-time is not smooth. It is a seething quantum foam, where energy fluctuations cause particles and wormholes to blink in and out of existence. In this realm, geometry itself fluctuates. The smooth, predictable space-time we experience may be merely a calm, average surface over this turbulent, probabilistic ocean beneath. This chasm between the smooth geometry of general relativity and the chaotic probabilities of quantum mechanics represents the greatest unsolved problem in physics. Uniting them into a single theory of quantum gravity is the ultimate quest. Approaches like string theory and loop quantum gravity propose that space-time itself is emergent, woven from vibrating strings or discrete loops of quantum information. Discovering this theory would not only explain the birth of the universe, but would also bridge the cosmos and the atom, revealing the final, unified law from which all reality springs. And as these theories are pondered, the evidence of dynamic space-time passes through you unnoticed. Gravitational waves, ripples from colliding black holes and neutron stars, stretch and squeeze the very fabric of space as they travel. They pass through your body constantly, compressing the space between your atoms by an infinitesimal amount, an unseen symphony of cosmic events playing through you, a silent testament to the universe in constant, graceful motion. Every second, ripples in the fabric of space-time wash silently across your body, stretching and squeezing the distance between your atoms by unimaginably tiny amounts. These are gravitational waves, born from the most violent events in the cosmos, the collision of black holes and the merging of neutron stars. Predicted by Einstein and first witnessed by humanity in 2015, they confirmed that space itself can vibrate like the skin of a drum. Though they carry the energy of whole suns converted into motion, their effect on us is a whisper, a distortion smaller than 1 part in 1,000 trillion trillion. Each passing wave is a message from a distant cataclysm, a faint signal from places we will never see. The earth, the sun, and the very rhythm of your heart move gently with these waves, all united in a vibration older than time. You do not feel it, but you are forever dancing to gravitational music of the universe. A magnetar is a celestial phenomenon of almost mythical power, an ultramagnetized neutron star, the remnant of a colossal star's death. Its magnetic field is 1,000 trillion times stronger than Earth's, a force so potent it can twist the shape of atoms, bend the paths of light, and distort the structure of space itself from half a galaxy away. Its field could erase the data on a credit card. Up close, it would tear matter apart at the atomic level. Occasionally, their crusts crack under unimaginable magnetic strain. releasing starquakes and flares of gamma radiation that can momentarily outshine entire galaxies. They are rare, but they stand as stark reminders of the extreme forces that nature can wield. A magnetar is the universe's most powerful magnet, a celestial sovereign whose dominion is written in lines of invisible, irresistible force. Deep within the sun, the weak force performs a slow and patient magic. Under immense heat and pressure, hydrogen nuclei collide, but they cannot fuse without a subtle transformation. The weak force allows a proton to change into a neutron, creating the heavy hydrogen essential for the fusion chain. This single, slow step, taking billions of years per atom, unlocks the process that builds helium and floods our solar system with light and warmth. The weak force's role is quiet, operating on a timescale we can scarcely comprehend. Yet it is a fundamental reason the sun shines at all. The gentle light that warms your skin is the cumulative glow of countless trillions of these tiny, weak interactions. Every atom in your body carries a memory of a star's life and death. The carbon in your cells, the oxygen in your lungs, the iron in your blood were all forged in stellar cores and scattered across space by supernova explosions. The weak force made this possible. It is a quiet alchemist that enabled the fusion of hydrogen into the very elements of life. You are not just living in the universe. You are literal stardust, assembled over billions of years. The weak force is a quiet thread that connects your existence to the furnace of creation, proof that the matter of life and the matter of stars are one and the same. Without the strong nuclear force, the universe would be a formless, expanding sea of pure radiation. Quarks would never bind, protons and neutrons would not exist, and there would be no substance, no weight, no texture. The strong force changes everything. It acts as a cosmic crucible, trapping immense energy within particles and converting it into mass. It is the fundamental reason the cosmos feels solid beneath our feet. Its unbreakable bonds determine how stars burn, how atoms form, and how the entire periodic table comes to be. Every stone, every tree, every living being exists because a strong force transforms the chaos of pure energy into the enduring architecture of matter. The master sculptor once matter exists. Gravity takes over as the master sculptor. Its slow, patient, and relentless pull gathers cosmic dust into clouds, condenses clouds into stars, and gathers stars into glittering galaxies. Without gravity, the matter created by the strong force would drift forever in a dark, diffuse haze, never coalescing into planets or people. Gravity shapes potential into form, pressing matter until fusion ignites and light is born. It forges order from chaos not through violence, but through unwavering persistence. From swirling nebulae to orbiting worlds, every large-scale structure in the cosmos is a testament to its quiet, shaping hand. Gravity, electromagnetism, the strong force, and the weak force are the four fundamental voices of reality. Each plays a distinct and essential part. Gravity gathers. Electromagnetism builds and illuminates. The strong force binds. The weak force transforms. Change the tune of anyone, even slightly, and the entire cosmic symphony would fall into dissonance. There would be no stars, no chemistry, no life. Every heartbeat, every distant galaxy, every spark of thought is written in the language of their perfect, delicate balance. They are not separate laws, but different verses of one vast, unfolding poem, sung without end by the universe itself. When you look deeply into heart matter, you find there are no truly solid things. There are only relationships, a ceaseless, dynamic play of forces. Particles are but temporary ripples in invisible fields, sustained by interactions that never cease. The four fundamental forces are the verbs of existence, the actions that create and recreate reality at every moment. Atoms hold together because of an endless exchange. Stars shine because of a perfect balance. The universe is not a static collection of objects, but performance, an ongoing dance of gravity, electromagnetism, and the nuclear forces that has been playing since the dawn of time. And now, as the currents of the universe grow quiet again, you can rest in the calm that follows wonder. The forces that shape reality never sleep, yet somehow they lull us into peace. Gravity keeps your body close to the earth, a quiet tether to the planet's slow, steady heartbeat. Electromagnetism hums softly through the air, carrying the warmth of light that touches your skin. Even now, The strong and weak forces are at work within you, holding your atoms together, sustaining the quiet chemistry of life, keeping your world intact. Everything around you, every sound, every breath, every thought, exists because of a balance. The same equilibrium that holds the stars in their silent orbits also holds your heart in its steady rhythm. You are not separate from the universe. You are an expression of it, a pattern of forces, made conscious for a brief and beautiful moment. Somewhere, distant galaxies continue their slow drift into darkness. Stars are born, live, and die to the same cosmic music that moves through you. Every moment is part of that rhythm. Every heartbeat echoes a law written into the fabric of reality long before life began. You are made of stardust, bound by gravity, illuminated by electromagnetism, and sustained by nuclear fire. You are, in every sense, made of the same story the universe tells itself. Let your thoughts unwind. Let them fall like dust through starlight. Feel the weight of gravity as a comfort, the pulse of light as a lullaby, the stillness between breaths as a doorway to sleep. The cosmos continues its endless motion, vast, beautiful, and utterly at peace with itself. If you enjoy these quiet journeys, I invite you to subscribe, or share a thought below. It helps others find their way here. 2. One sleepy soul at a time. For now, just breathe. Let your eyes grow heavy, and let the forces of the universe cradle your thoughts. Slow, weightless, and free. Good night.